11 is on top. 13 comes back to the middle. 15 is on the bottom. 17 goes back to the middle. 19 is on top. Here at 1 it comes back to the middle. -1 is at the bottom. -3 is at the middle again. So everybody sees I have plotted my points. What I need to do now, join them. Something like that would be my sinusoid. I need to write the equation, which I already found. The equation of this sinusoid is y is equal to 23 plus 20 cosine of pi over 4 into x minus 3. Done. I have written the equation. I have drawn the graph. These applications are very, very important. I need everybody to remember what we are doing here. Before we go ahead to answer the question, let me read the question again. As you ride a Ferris wheel, your distance from the ground varies sinusoidally with time. When the last seat is filled up, when the last seat is filled up, when the last seat is filled up and the Ferris wheel starts, your seat is at the position shown. Let t be the number of seconds that have elapsed since the Ferris wheel started. You find that it takes 3 seconds to reach the top, 43 feet above the ground, and that the wheel makes a revolution once every 8 seconds. The diameter of the wheel is 40 feet. Sketch a graph of the sinusoid. That's the first question. Have we done that? Yes. We have sketched the graph of the sinusoid. Now, how did we do it? We look at all the information given to us. They gave us the maximum. We use the diameter to get the minimum. Minimum is 3, maximum is 43. From there, we find the amplitude, because there's a formula to find the amplitude. Everybody write it down. Now, after we find the amplitude, we can go and find the C value, the vertical shift. We got a vertical shift. Please take a note. Take a photograph of what I'm doing. How I solved the Ferris wheel problem here in the class. You get the C value. C value is 23. You need to find the D. They gave us the D. The D for cosine, because why is it cosine? Because it says you take a reference from the top 3 seconds later. That means that at 3 seconds, that's where your D was. That's where you started. That's the only reference you know for sure. That you be at the top at 43, 3 seconds late from beginning. Now, you have to find the CP. First of all, you got to find the B. They gave us that the period for one revolution, one rotation. Sometimes they use the word rotation. Sometimes they use the word revolution. They're all talking about one complete, one period. They're talking about one period. How long it takes to make one cycle. One revolution is one cycle. One rotation is one cycle. Now, they gave us that the period is 8 seconds. Can we find the value of B? How many cycles in 2 pi? Yes, we can, because the formula says B is equal to 2 pi divided by P. 2 pi divided by 8 will give us pi over 4. We have the pi over 4. We can also use the period to get the CP, because CP is period divided by 4. 8 divided by 4 gives us 2. That's how we know how our critical point is going to change. How it's going to change. From 3, you add 2, you get a 5, add 2, you get a 7, add 2, you get a 9, 11, 13, 15. That's what your exercise is going to look like. Now, after you have done that, you have all the information to write the equation and draw the graph. We have written the equation, we have drawn the graph. Now let us start to answer the questions. Everybody ready? The graph is on our mind. Let us look at the question now. Question A says, gauge the graph of this sinusoid. Have we done that? Yes. What is the lowest you can go on the Ferris wheel? And why is this number greater than 0? What is the lowest? Who can answer that question from my common sense? 3, why is it greater than 0? Why is the Ferris wheel above the ground? 3 feet above the ground. Why is that? It never touched the ground. Why not? Very good. It won't be able to move if it touches the ground. Somebody got it designed that it will not touch the ground, because friction and will produce heat, and people may be burning. Friction. Too much friction, if it touches the ground, it's going to cause friction and heat. That's why you cannot design a Ferris wheel to be touching the ground. This is common sense and natural sense. So, it says, why is this number greater than 0? Because it has to be greater than 0. It has to be above the ground, so to avoid friction and heat production. You don't want heat. And it also messes up the entire Ferris wheel if you keep hitting the ground. You know that. Okay. Write an equation of the sinusoid. Yes, we have written the equation. Everybody take note of this now, because you're going to do one. Now, take a look at it. Let's look at the next question. Predict your height above the ground when t is equal to 6. How do you predict your height above the ground when t is equal to 6? Okay, I need everybody to pay attention. I'm going to show you how you can use your calculator to answer this type of question now. Are you ready? Because you got to use your calculator. I'm going to see if I can get a calculator on the screen for you. Everybody, if you have a calculator, get your calculator out now, because I'm going to teach you how you can use your calculator to answer the rest of the questions. Can everybody see my calculator?
No.
Can you see it now?
No. We see the worksheet.
You don't see the calculator?
No.
People at home, you don't see the calculator on the screen. People in class, do you see the calculator?
We do not see the calculator.
We do not. Okay, let me see what I can do to make sure you see that calculator. It's very important you see it. It's very important you see the calculator. I'm gonna stop presenting now. Present again. Go to window. I'm gonna go to this. Now, do you see my calculator?
Yes.
You see the calculator?
Yes.
Okay, very good. Everybody, please put your eyes on that calculator. I want to make it larger. It's not going larger. Did it go larger? Or did it become bigger? Do you see the calculator, people at home?
Yes.
Yes.
Okay. Okay, ladies and gentlemen, I'm going to teach you how you can use your calculator to answer the rest of the questions. Ready? Now, the first thing I got to do, I wish I can see this. I wish I can see it. Where's my glasses? Oh my God, I wish it was here. What if I put it here? Okay, people in the class, if you need a calculator, come and borrow one from me now. So you can have a calculator in your hand and follow through. Come on, everybody. People in class, take a calculator from me. Come on. Get up, come and take a calculator. People at home, get your calculator out, or you're gonna look at the one on the screen. There's nothing else I can do. I can't give you a calculator physically when you are not in class physically. Everybody, please, you need to listen to me. You need to learn how to do this. Okay. Everybody, remember the equation we put it? Go to Y1 and put that equation quickly. Go to Y1. Enter that equation. Go to Y1. Enter the equation. Go to Y1. Enter that equation. Everybody follow my lead. 223 plus 20 cosine. You gotta watch carefully now how I'm gonna put this in. I have a parenthesis. I gotta do second caret to put it pi. Pi divide by 4. Look at how I'm entering it. You gotta enter it like that. Put another opening parenthesis. You're gonna put in x. Uh-oh. Say it again. You have a calculator in your hand. You gotta follow through what I'm doing. Okay. You see, I can't see it if it's over there. Look. You can see it there now, right? Okay. I can't see this from this far. Okay, let me come closer there. See what I'm putting. So I put 23. 20 plus 20. Okay, cosine of pi over 4. I open a parenthesis. I open another one after I put pi over 4. Now I'm going to put in x. X minus 3. Everybody put x minus 3. I'm going to put, is this x here? Minus. This is minus 3. Then I'm going to double close. 1, 2. Double close the parenthesis. Everybody, please make sure you got this. Let me repeat what we enter. Everybody at home, you must follow through. You go to y equal to you are going to put in 23 plus 20 cosine. You have a parenthesis open up. Then you're going to put pi. Divide by 4. Open another parenthesis. X minus 3. Then you double close the parenthesis. Now go to y2 and put 0. Go to y2 and put 0. Everybody got that? All right? Everybody please watch. Go to y2. Go to y2 and put in a 0. That's 0. And leave it like that. Now, before you do any other thing, I want you to press in window. You got to press window. Let me press window here for you. This is window. What is the lowest X you want to put in? Since this is not going to reach the ground, put in 0. What's the maximum? Put in 40, put in a 50. Now you turn around, the increase in X oh, okay, we're talking about X. Let's go from negative 3, all the way to, let's go to 23. That's our X. Negative 3 to 21 and then 23. 21, 23. Let's go to 23. Then the increase in the X, since our CP is 2, put in 2 as our increase. Now you go to Y now. The minimum Y, let's make it a 0. Maximum Y, make it a 45. The increase can be 1, doesn't matter. The Y scale may be 1, doesn't matter. Everybody must watch what I'm doing. Now watch what I'm going to put my window. Okay, window on the X. I'm going to delete. What's my window there? Delete what is in there first. What's my X minimum? We put negative 3. Negative 3. Come down. What is my X? Is that the X max? The X max, what do we agree? 23, yes? Now what's the X increase? What do we say? 2. Come down. What's the Y minimum? 0. We agreed. What's the Y max? Let's make it 45. What's the Y increase? It doesn't matter. We make it 1. And then the other one is 1. Okay. I have set my window. Look at how my window is. But before you do anything now, go to mode. Go to mode. Everybody sees mode, right? Is this here mode? Is this mode here? I can't see from here. Is it mode here? Okay. If that's mode, make sure you are in radian, not in degrees. You are in radian. You come down to radian and hit enter. Make sure you're in radian. You can't do this in degrees because it will not work. Now, you have entered all the information. go now and say graph. You are going to see the graph presented to you the same way we drew it. You're going to see the graph. Everybody, Vincent, pay attention. Vincent, are you awake? Okay, look at the graph. Everybody sees the graph. Calculator has drawn the graph for you because you already set up the proper everything in order. The calculator cannot do anything unless you tell the calculator what to do. Calculator cannot think for you. You must have all this information down first before you enter it into your calculator. Everybody, please listen. Now, we are going to look at the questions now. After we've done the graph, I'm going to show you how to make this information, how to answer these questions now. The D question says, predict your height above the ground when T is equal to 6. Now watch carefully. You go to your calculator. Go to your calculator. The one on the screen. What do? You are going to. Everybody can see the two calculators. Can people at home see the two calculators? Hello, people at home. Can you see the two calculators or you only see one?
Only one.
Only one.
You don't see the yellow one, right? You see the black and white or the gray?
Yes.
Yes.
Okay, good. Well, I'm gonna do it from the one everybody can see. Now, the question is, how do I answer these questions? The first question is, where is the Ferris wheel 6 seconds after it started? How far is that? Okay, what do you need to do? Go to second trace. Everybody go to second trace. Second trace. And then press 1 for value. Press 1 for value. And in this case now, the calculator is going to be blinking on X. Everybody listen, you're going to do this in the next 20 minutes or in the next 5 minutes. You're blinking on the X. They want you, what is the value when X equal to 6? That's what you do now. You're going to put in 6 in there. Did I put 6 in there? Did I put 6?
Yes.
Okay. When you put 6, you're asking the calculator to tell you the Y value when X is 6. What you need to do for the calculator to do that for you, after you put in X equal to 6, you're going to hit enter. It tells you the value. Somebody tell me the value you get.
8.8578644.
Everybody must get the same answer. There's no doubt. That's the correct answer. The answer is 8.8579. Let's leave it like that. 4 numbers after the decimal. That's your answer. 8.85779. Now, we're going to do the same thing again. When T is 4 1/3. 4 1/3 is the next question. What is the value when T is 4 1/3? Everybody do that now without my help and give me an answer. Follow what I just did. 4 1/3. Okay. Somebody give me an answer. Somebody got to give me the answer. Somebody talk to me. What's the value of y when t is 4 1/3? Are these people here? Are my people here? Talk to me, people. Can someone give me the value? What do you get? Did you enter the equation? Did you put in radian? Did you check your calculator is in radian? You sure? You got to do it again. Did you set the window right the way I taught you? Someone at home, tell me the value of y when t is 4 1/3. Achimpong, what did he get? Huh? What did you get when t is equal to 4 1/3? Did you put 4? How do you put 4 1/3? No, you got to put 4.3333 all the way to the end of the calculator until you cannot go further. You got to put 333 because they're repeating decimal. You got to go to the end of the calculator with 33333. And then look at the answer now. Exactly? Did he give you exactly that? Okay, that means you learned something. Let me see what you have. 23 plus 20 cosine of 5 over 4. No, you did not set it up right. You did not. I told you that if you put it wrong in your calculator, the calculator will not do the right thing. Clear that. Clear this. See how I set it like this? And you go to the end. And you double close. Look at it now. You were talking about? Everybody must get this. If you don't get it, talk to me now. You must get it in your calculator. What is the value when